One more topic for review is slope and lines. Anytime you deal with lines, you're going to have to deal with the notion of slope, which is the ratio of rise to run between any 2 points on a line. So if you have two generic points, x1, y1, x2, y2, the slope between these points is calculated as the change in y over the change in x, or I said more commonly called rise over run. And it literally means take the difference in the y values for your 2 points and divide by the difference in the x values for your 2 points. The reason these subscripts are used is to make sure you do the order of subtraction consistently when you're calculating the change in y over the change in x. So for example, if I want to calculate the slope between this pair of points, it really doesn't matter which one gets the x1, y1, and which one gets the x2, y2. You just need to make sure you get the order of subtraction consistent. So for example, in calculating slope, which is denoted by the letter m, my change in y. So for example, if I decide to let this be y1 and this be y2, I can say the change in y would be 8 minus 2, and then I have to do the change in x as negative 6 minus 3. The order of the y subtraction fixes the order of your x subtraction. So you have to do negative 6 minus 3 in the bottom, and then you're ultimately dividing 6 by negative 9, and that gives you a ratio of negative 2/3. Okay? Now, just for the sake of argument, does it matter which one gets the x1, y1, or x2, y2? No, it doesn't. If I decided to do the change in y over the change in x the other way, it's going to give you a consistent answer. So now, let's say I let this be the y2, the number 2, and let this be the y1. So if I decide to do 2 minus 8 up top, then again, that order of subtraction for the difference in the y's has to fix this order of subtraction for the difference in the x's. I have to do 3 minus negative 6. And you are doing minus negative, so yeah, that'll become addition. So see, in this case, you have a negative 6 numerator over a positive 9 denominator. But that still gives you a negative 2/3 slope. So either way you calculate the slope, doesn't matter which way, you have to just be consistent with the order of subtraction whenever you're doing difference in y over difference in x. Okay? Calculating slope from a graph, because obviously slope is inherently tied into the graphs of lines, so you need to be able to calculate the rise over run ratio between any pair of points on the graph. So if you look at this graph at the bottom of the page, I've got a series of points labeled on this line. So if you pick any pair of them, doesn't matter, a pair of consecutive points or any pair of them. So let's say I choose this point right here and this point right here. Without actually employing the formula, the true understanding of slope is to understand how you can measure the change in y and the change in x just by counting the tick marks on the graph paper. So I just chose these 2 points, this one here and this one on the y-axis. So if I want to calculate this change in y going from this point upward, since I am going up, that's a change of 1, 2, 3, positive 4 units in the y direction. If I measure this change in x, this horizontal distance, going from here, that's 1, 2, 3, 4, 5, 6 to the right. So that's positive 6 in the x direction. So in this case, my change in y over change in x would be a positive 4 change in y over a positive 6 change in x, and that ratio's down to a 2/3 slope. For some reason, I'm in love with the number 2/3 today. But anyway, that's how you can calculate the slope from the graph of a line, just by counting off the spaces. So if we had gone between these 2 points right here, the ones that are a little closer together, notice you wouldn't have to reduce the fraction at the end. From here to here, you go up 2, so positive 2 rise, and then you make a turn and go 1, 2, 3 clicks to the right, positive 3 run. So see, you still get a 2/3 ratio for rise over run, change in y vertical over change in x horizontal. So the slope is consistent between any pair of points. That's one of the beautiful things about the slope of a line. Okay, venturing forth, the next natural thing you're going to need to be able to do is to determine the equation of a line once you've determined its slope. The 2 major attributes that you need to get the equation of a line, the 2 things required to determine the equation, are going to be 1 point on its graph and the slope. So sometimes you're given this information right at the beginning of the problem, or sometimes you may have to decipher the information yourself. So for instance, if I jump down to the example at the bottom of the page, we're asked to determine the equation of the line between these points 3, 2 and negative 6, 8. And notice this is the same pair of points that we looked at here on this first example. So we've got a point on the line. You've got 2 points to choose from. Both of these are points on the line, so either one will do. But to get the slope, we'll need to go back to that previous example to get the actual slope value. So technically, we've already got everything we need. What I need to do, though, is to review over what to do once you have the point and the slope in finding the actual equation of the line. So once you know those two things, you're going to plug the slope and your point, any point, into what's called the point-slope formula. And this will get you on the beginning of your equation solving process. This will get you an equation for the points of the line in this format. So this is the point-slope formula. You're going to take the point that you've got and the slope m and plug them into this pattern. Then after doing this, this is the initial setup. So this is like step 1 of finding the equation for the line. After you have this set up, the format that you're most often going to be prompted for is called the slope-intercept form. You get this by simply solving that equation for y. Once you solve this equation for y, some of the numbers are going to intermix and you'll get something in the form of y equals mx plus b. That's referred to as the slope-intercept form, where m represents the slope and the value b represents the y-intercept of the line's graph. So, to use the point-slope formula properly, we need a point and a slope. So since this is the same pair of points from our previous example on the first page, we've already calculated the slope to be negative 2/3. So we already know m is negative 2/3. And then for the point that we need, the x1, y1, does not matter which point you choose. Both of these are points on the line, so either one of them will work as the x1, y1 point you need in the point-slope formula. So the way the formula is formatted is you have the letter y, a generic y, minus your value of y1. y1 is 2. y1 is that y-coordinate 2 from the point on our line, equals m, and there's our slope, times the quantity x minus x1. So a generic x minus x1 is paired with the number 3. And so this is the full point-slope formula for this line that we're trying to find. We are prompted to go to the slope-intercept form. So your only extra steps are going to be to solve this equation for y. So again, let me make sure you're aware of that. This is point-slope form. Put a big red square around that. And then to get to slope-intercept form, you just solve for y. So the first thing you need to do in solving for y is to distribute this negative 2/3 into that binomial. Negative 2/3 times x, we'll just write that as negative 2/3 x. Negative 2/3 times negative 3 is going to be positive 6/3, and 6/3 reduces down to 2. So I've distributed the slope into the binomial, and now I want to get the y by itself. Your goal is to solve this equation for y, so I'll add that 2 to both sides and get y isolated, and then that finally leads me to y equals negative 2/3 x, and then 2 plus 2 is 4. And then this is referred to as the slope-intercept form. Because it tells you the m coefficient of x right there, y equals mx plus b. That m coefficient of x is always your slope, and then the b value at the end is the y value of the y-intercept. So to graph a line, I mean, one way to do it is just to plot the 2 points we were given. We could plot the 3 and the 2, positive 3 for x, positive 2 for y, and then the negative 6, positive 8, 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6, 7, 8. And then taking a straight edge, you can connect that and make your line's graph. Looking for a straight edge now. It's kind of a big one, but I think I can use that. All right. So let me show you an alternative, though. I mean, we can obviously connect those points, make the line, it's fine. But I need you to be adept at using this slope-intercept form to get the graph of the line. So the convenient thing that this offers is it tells you a point that's on the line graph right there. That tells you that this line's bound across the y-axis at 4, because in y equals mx plus b, that 4 represents your y-intercept. So if you look at the pattern that these points suggest that the tilt of the line is going to go, it looks like 1, 2, 3, 4. It looks like that line would have to cross the y-axis at 4 if you put your straight edge on there. And then if you use the slope is negative 2/3. So that means starting at the y-intercept, if you hadn't already plotted some of these other points, you could use a stair-step pattern for the slope to get other points on the line. So since your slope is negative 2/3, you could go down 2, there's a negative 2 rise, and then since only one value gets negative, you make the run positive. So if I keep the negative on the rise, I want to keep a positive on the run. So down 2, negative 2 rise, and then 1, 2, 3 to the right, positive 3 run. There's the other point that I could plot. And you can keep doing this stair-step pattern for any number of points on the line. Keep going at a slope of negative 2 rise, positive 3 run, and to get other points. If you wanted to go to the left, you might want to consider making the rise positive and the run negative. So see, if I started at the y-intercept and used a positive 2 rise, I'll need to use a 1, 2, negative 3 run so that I match the correct pattern of the tilt of the slope. So we got 5 points plotted there just by using slope, and then we want to connect them with a straight edge and get a proper line graph. And I put these little arrows on the ends just to let you know that the line keeps on going infinitely in both directions. Okay. What we're talking about next is another find the equation of the line. And just to give you a little extra practice, this one sets up a little bit differently. You're determining the equation of a line that has a slope of 1/3 and an x-intercept at -7. And then you're asked to graph the line. So, technically we could graph the line right now. Just keep in mind, this is an x-intercept, so that's the location on the x-axis. 1, 2, 3, 4, 5, 6, 7. That's the location on the x-axis where the graph crosses. And then a slope of 1/3 means you want to go up 1 and then over 1, 2, 3, up 1, over 1, 2, 3, up 1, rise, 1, 2, 3, run, 1 rise, 3 run. Any number of points you want to get. I guess I could go one more. So we could just graph the line right off the bat, because you know the slope, you know a point on the line, and then that's enough to give you a series of points to connect with your straight edge. And so this line is going to end up looking something like this, without even knowing its full-on equation just yet. All right. But the goal is to find the equation of the line. So remember, to use the point-slope formula, you need a point and a slope. So the thing is to interpret this correctly. As a point, you're going to want to write that as the coordinate -7, 0, because it's an x-intercept. Any intercepts are always going to have a 0 for one of the coordinates. An x-intercept means you'll have a 0 for the y-coordinate. So that means this can be our x1, y1 that's used in the point-slope formula. And we have the slope given to us right there. So to start the point-slope formula process, copy it down here for reference. We're going to use the y1 is 0 and the x1 is -7 and the m value of 1/3. So if I plug everything into the point-slope formula correctly, looks like that to begin with. So again, there's your point-slope form for the line's equation. You're looking to always end up in slope-intercept form. So I want to solve this for y, and notice you got a 0 with the y, so technically the y is already by itself. All you need to do is distribute the 1/3 through to here, and keep in mind minus negative means plus. So 1/3 times x is 1/3 x, 1/3 times +7, Just write that as an improper fraction. Just write it as 7/3. And so that means this graph should cross the y-axis. 7/3 is 2 1/3, so 1, 2, and 1/3. Yeah, that looks pretty accurate as to where it crosses the x-axis. So that gives me confidence in knowing that that's the right line equation we're looking for. Okay, we'll come back and talk about intercepts in the next video.